Hello, today we have a lesson about writing clean and readable code. As you know, in CS50, we not only do we want you to become programmers, we actually want you to become good programmers so that you can not only learn how to solve your problems, but solve them and write code that is elegant and that is readable and that is good code. So let us start. Um, why clean code is important? First, code is for humans to read, it's not for the computer, so it must be readable. Clean code is easy to understand. Code that is easy to understand is easy to maintain and debug. That's a very important point here because as projects get bigger, it gets harder to maintain them. And that's the other point is that code quality can define the life of a project. So sometimes uh, projects that have very bad code can become unmaintainable and can become discontinued, and we do not want that in our own projects. And clean code ties into design. So, you're graded on design and style, and writing clean code is what gives you design points. If we rush our code, we have bad code, and our bad code will lead to an unmaintainable project, which is not something we want for something we think that is going to be long-term, especially for your CS50 final projects. And again, with deadlines, usually this is also true for P sets. It's true for your CS50 projects. You rush. Once you rush, you write bad code. And once you write bad code, it becomes very hard to read the code again, maintain it, and fix it and make it more efficient. Features of clean code. Clean code is, first of all, readable. More on that later. It's easy to navigate your code and to know where to go if you're trying to find something. It's understandable if you read it, and it should be concise and straight to the point. So here are some tips for readable and understandable code. Line breaks and spaces. So we're going to cover this first. As you see in this code snippet, we have two functions defined, and they are just under each other. There's no line breaks there. So we would want to separate these functions to make it more readable. There's spaces. Our brain can navigate the code better if there are spaces defined. And since Python also forces you to indent your code, we don't need to worry about indentation here. How about spaces? Look at this snippet of code. There's no spaces between the assignment operator, the equals operator, the plus operator, the x, the 3. This is just not good. So we want to do this. We want to break it up and add spaces. Spaces between operators and variables, as you saw in the last example, is very recommended. Now to the next point, we have small and specialized functions. A lot of new programmers tend to write very big functions. That's not what we want. Functions should not be too large. They should not do several unrelated things. They should be hyper specialized, and having several functions and each one being specialized doing a specific thing is much easier to debug these functions and use them in the big picture code. Second point is expressive variable and function names. Variable names should reflect the purpose, the data which they hold. For example, x equal Mario, y equal 19. We don't know anything about x and y. Here we rename the variables, name equals Mario, age equals 19. Function names should reflect their purpose as well. Function names, class names, variable names should all reflect the function that they carry out. So this is a degrees function. Just reading the name, it doesn't say much, just tells us it has something to do with degrees. However, if we write def rad to deg, writing it like this probably tells us it converts radians to degrees. Now, don't go overboard. The name shouldn't be too long. Names should be, this is too long. We shouldn't go with something like this because it's just a very long name. It's very hard to type. And even though it is easier to read, this is not easy to write. Good code is easy to read and is easy to write. Irredundancy. So what do I mean by redundancy? Look at this function here. We're checking if x if the modulus of x divided by 2 is equal to 0. If it is, then I want the function to return true, meaning that the function we passed, the argument we passed is true, is an even number. Otherwise, it returns false. Now we can shorten this and we can write return x mod 2 equal 0. X mod 2 equal 0 will return, this expression itself will return true if the argument x is actually even. So we don't need the if else expressions here. We have to review our code to know when we can write more efficient code, what can we substitute, how can we make it more concise but still have it to be readable. You should ask yourself, is there a shorter, better way to write it? If there is, you should do it. Sometimes being too smart with your code can make it unreadable. If you try to shorten things a lot, then you'll have a lot of trouble remembering what they do. And that's why, that's probably where comments go in, and we'll cover comments later. Comments is now. Comment when something needs clarification. Your comments should answer why questions rather than how questions. The how questions should be clear. I should read your code and I understand how the code is doing something. And some style tips for comments. This is a good comment. It's placed right above the code. There's a space between the pound symbol and the first word, and the first word is capitalized. Don't do this. Don't write inline comments, and don't write comments that are just compact and it's just all lowercase. And comment only when necessary. A lot of comments in your code can make your code unreadable. This is, for example, a bad comment. Sum equal 2 plus 3, we're saying it calculates the sum and 2 of 3. It doesn't add any new information. It doesn't clarify anything here. Docstrings in Python. This is in Python, specific to Python. What are docstrings? They are these 3 quotation mark symbols, and we use them to document classes and functions. For example, here, def is even, returns bool if even. Now, we could probably create a better docstring, but this is just to explain what they do. Type annotation. This one is specific to Python and makes your Python code more readable. What are they? Type annotations help us annotate the type of certain variables, and help us annotate the return type of a function. So the variable sum is of type int. We use the colon here, and we write it out as sum int equal 2 plus 3. This is a function. We say that the argument is of type int, and the arrow bool means that this function returns a bool. And documentation. What is documentation? What do we mean by documentation? It's information on how your code or projects work. It's not comments. Comments are just usually in code. Documentation are separate documents. They can include information about functions, the function's arguments, the return value, and the functionality that is implemented in that function. They can include information about classes, the attributes, I apologize for the error, the attributes and the methods of those classes. They can include design decisions for your project. They can include style decisions that are related or specific to your project. And they can include information of how to use and set up the project. Finally, I will end on this note. The smallest team you will ever be a part of is 3 people: your past self, your present self, and your future self. This is a very important note to keep in mind. Just because you're one person working on the project does not mean you can forego the tips mentioned today, because you will find yourself in the future looking at the code you wrote in the past, and you can't even understand your own code. And this happens a lot. Your future self will regret your past self. Thank you for your time.